So, a very interesting type, this one. What is the remainder when such a number, some base raised to the power, some power, is divided by a divisor? Let's say 7 is the divisor in this case. The concept is that look for higher powers of the base to get a remainder of positive 1 or negative 1 with the divisor. So see, 2 is the base and 7 is the divisor. The distance is 5. It's neither positive 1 nor negative 1. 2 squared would be 4. Now the distance is 3. Still, it is not positive 1 or negative 1. Then 2 cubed is 8. See, 8 is 7 plus 1. We got a desired positive 1 difference here. So if we convert the base 2 into a base 8, we will start getting a remainder of positive 1 with the divisor 7. Let's apply this. In this question, we have to find the remainder of 2 to the power of 300 with 7. We express it as 8 to the power of 100 divided by 7. Why 8? Because 8 leaves remainder 1 with 7. Now, this can be written in the following way. 8 times 8 times 8, 100 times, divided by 7. Now, each 8 leaves remainder 1 with 7. So we can say that the remainder is going to be 1 times 1 times 1, 100 times. Therefore, practically, the remainder is going to be 1. That is the answer to this question, 1. Let's take one more example. Let's say remainder of 2 to the power of 303 with 9. In this case, you see we get 2 cubed is 8, and 8 gives negative 1 remainder with 9. We write this as 8 to the power of 101 with 9. This is practically 8 times 8 times 8, 101 times, or negative 1 times negative 1 times negative 1, 101 times. Because every 8 gives a remainder of negative 1 with 9. Then, this is being multiplied odd number of times. Negative 1 times negative 1, 101 times, odd number times. Therefore, effectively, this product is going to be negative 1. An important concept here. Whenever you get the remainder as something negative, add divisor to it. This is something I have covered in one of the earlier videos. So the remainder is negative 1 plus 9. The answer is 8. In light of this concept, let us now try some practice questions. Please pause the video and try solving these yourself. So, 3 squared is 9. That gives us remainder 1 with 8. So we can write this as 9 to the power of 25. We need to find the remainder with 8. Each 9 will give remainder 1 with 8. Hence, it is practically 1 to the power of 25, and therefore the answer is 1. The next case, 92 to the power of 60, and we need remainder with 15. 92, the base, is greater than 15, the divisor. So, first of all, divide the base, 92, by 15 and reduce it. This becomes 2 to the power of 60, because 92 leaves remainder 2 with 15. Now let's try higher powers of 2. We can see 2 to the power of 4 leaves a remainder of positive 1, because 2 to the power of 4 is 16, which is 15 plus 1. Therefore, the fourth power of 2 is going to help. So we write 2 to the power of 60 as 60 to the power of 15. Now, when we divide this by 15, it is practically 1 to the power of 15. Therefore, the answer is 1 again. Please don't think that the answer is going to be always 1. Very often, of course, you will have other answers, probably in the next question. So first of all, reduce the base. 70 divided by 17 gives remainder 2. So once again, it becomes 2 to the power of 60. Again, 17. So 16 is going to help because 16 will give a remainder of negative 1. So the expression becomes 16 to the power of 15. And we need to find the remainder with 17. Practically, this means negative 1 to the power of 15, which is negative 1. Remember, whenever you have the remainder as something negative, you must add the divisor to it. So practically, the answer is going to be negative 1 plus 17 equals 16. Look at the next question. First step, divide the base 100 by 7. You get remainder 2. So the expression becomes 2 to the power of 100. 2 cubed is going to help because 2 cubed is 8, which is 7 plus 1. So we write this as 2 cubed to the power of 33 times 2 to the power of 1. See, this is power 99, and this is power 1. So overall, the power is 100. 2 cubed is 8, which leaves remainder 1. So the remainder is, practically, 1 to the power of 33 times 2 to the power of 1. Therefore, the remainder is 2. The answer is 2 here. Next, 2 to the power of 60. And we need remainder with 15. That's an easy question. We just solved this. It is the same as this question. The answer is going to be the same. We write this as 16 to the power of 15. The remainder with 15 turns out to be 1 to the power of 15. Therefore, the answer is 1. If you got all the 5 questions correct, you have done a very good job. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.